So here is a solution to question 45. Here the first question is, write down the distribution of in the first question we have to write down the distribution of the random variable, find the expected value and the variance. So as you can see, we are given for 2-point baskets, we are given attempted so many, of which so many were successful. So the distribution of the random variable x shall be, it takes the value 0, 2 with the following probabilities. Why do we have a 653 by 1341 here? That is because 653 of them were successful. So now the expected value is the expected value, which is 0 times the probability plus 2 times the probability, and the variance is calculated by expected value of x square minus expected value of x whole square, which simplifies to this. For the next random variable, we have to do the same. Find the expected value and the variance. So the next random variable is the second random denotes the result of a 3-point attempt. So that is equal to, so that takes the value 0, 3 with the following probabilities, and the expected value is this, and the variance like the way we calculated above, which is the expected value of y squared minus expected value of y whole squared is equal to this. So that is 45's A and B. In 45C, we have 10 3-point baskets and 10 2-point baskets. What would be the expected value and what would be the variance of these 20 shots? So because we have 10 2-point baskets and these 10 shots are independent, which is the outcome of the first shot does not influence the outcome of the second shot, and so on and so forth all the way up to 10th shot, we have to represent them by x1 to x10, and we have 10 3-point shots, so we should denote by y1 to y10. So our random variable is x1 plus x2 plus x10 plus y1 plus y2 plus y10, and we have to find the expected value. Expected value of a sum is equal to the sum of the expected values, and that is what we have, 23.0207. And likewise, variance of the sum is equal to the sum of the variances when the random variables are independent, which was the case here. That's why we have variance of x1 plus variance of x2 all the way to variance of x10, and when we take the square root of the variance, we get the standard deviation, which is 5.67. So the next question is the following. Here, this question is very similar to the previous question. What do we have here? Here we have 24 field goals, of which 16 are less than 40 yards, of which 15 were successful and 1 was unsuccessful, and 24 field goals, attempted field goals, of which 8 were more than 40 yards, of which 4 was successful and 4 was unsuccessful. So let the random variable x denote the points scored when Tynes attempts a field goal of less than 40 yards, and he gets 4 points. If he misses, he gets none. Find the mean and the variance of x. X is the points scored when Tynes attempts less than 40 yards. It takes the values 0 or 3 with probabilities 1 over 16 and 15 over 16. So the expected value is straightforward application of this formula for expected value, and variance is also expected value of x square minus expected value of x whole square, which gives me 0.726. So for the second random variable, points denoted for field goal, points earned for field goal more than 40 yards. Here also we have 0 and 3 points, and because they were 4 and 4, so we have probabilities 1/2. So the expected value is 1.5, and the standard deviation, the variance is 2.5, and the standard deviation is 1.5. The next one, he attempts 3 kicks of less than 40 yards and 2 of more than 40 yards. So less than 3 kicks of less than 40 yards and 2 of more than 40 yards. So because all these kicks are independent, they are added together. We have x1 plus x2 plus x3, which are the less than 40 yards, the 3 less than 40 yards, and y1 and plus y2, which are more than 40 yards. So the expected value is the sum of the individual expected values. The variance is the sum of the individual variances, and we have calculated them from before. So we just plug in the numbers and we are done. So 41, drivers from a freight company makes a varying number of stops. For each shift, the mean number of stops is 6 and the standard deviation is 2. The first driver makes 10 shifts and the second driver makes 8 shifts. So the question is, what are the random variables? Well, the random variables are x1 to x10, which are the number of stops made by driver 1 in each of the 10 shifts, y1 to y8, the number of stops made by driver 2 in each of the 8 shifts. X is the total number of stops made by driver 1, x equal to sum of x1 to x10, y is the total number of stops made by driver 2, y equal to y1 to y8. Expected value of x is the sum of these individual expectations, which is 10 times 6. Standard deviation x is square root of the variance of x, and the variance of x is the sum of the individual variances because the random variables were independent. So the expected value is 60 and the standard deviation is square root of 40. What about y? The expected value of y is 6 times 8 because it is equal to the sum of the individual expected values. What about the standard deviation of y? It is the square root of variance, which is the sum of the square root of the sum of the individual variances, which is square root of 32. And what is the mean? So part B of the question, what are the mean and the standard deviation of the number of stops made by these two drivers taking all the shifts into account? These two drivers taking all the shifts into account, that is the expected value of x plus y, which is expected value of x plus expected value of y, which is 108. And what about the standard variance or the standard deviation? The standard deviation shall be the square root of variance, which is square root of variance of x plus variance of y, which is variance of the total number of stops made by driver 1 plus the variance of the total number of stops made by driver 2, which is 40 plus 32, which is square root of 72. So part C, if each stop by first driver takes 1 hour and each stop by the second driver takes 1.5 hours, how many hours do you expect these two drivers to spend making all the shifts combined? And the next part of the question is, what is the standard deviation? So my random variable is, so this is actually part C, this was part B. And this is part D. So my random variable t is equal to 1 times x plus 1.5 times y. So the expected value of x is the expected value of t, which is equal to 60 plus 1.5 times 48, which is 132, and standard deviation of t is the square root of variance t, which is square root of variance of 1 plus variance of x plus 1.5y, which is variance of x plus 1.5 square variance of y, which is 40 plus 1.5 square times variance of y, which is square root of 112.